So I mentioned earlier the biggest challenge that I've had using permeable pavement has been the construction process itself. If you can get the subgrade and the pavement to survive the construction process, you're pretty well there. As long as you've got some sense, you can get the O&M provided. But that's the biggest challenge. That didn't used to be the case. Not that many years ago, even understanding how to design the systems or getting them approved or having them be cost effective were the kind of the front edge of the wave. I think now integrating them into the construction process is certainly the part that I spend more time than anything else thinking about. And so that's really about designing haul roads and sequencing projects to really minimize or eliminate construction, certainly eliminate it on the subgrade, but really divert as much construction traffic away from the site of the pervious pavement. Now that's not practical in all cases because sometimes our project is only to build the permeable pavement. And so in those cases, of course, we need to be strategic to talk about ways to protect and maintain the infiltration capacity of the subgrade. In other projects, it is relatively straightforward to do that. Matt and I worked on a project in Arlington where, because of the configuration of the building and its relationship to the road and where the client desired the driveway to be, we were able to just fence off the entire permeable pavement area during construction. It was actually outside of the construction envelope, and there were we built a dedicated haul road in to the project, put our construction entrance there, and did 90% of our construction traffic over this dedicated entrance. And then as the building was getting completed, the contractor was able to back out of there, and then we opened up the permeable pavement area and were able to build that sort of as its own project later in the project as a distinct, once the majority of the utilities and the real earthwork for the rest of the project was in place. That's an ideal scenario. That doesn't always happen, but we need to be on the lookout for those opportunities and to really understand, I think, put a little more thought into site development plans about really providing clear staging areas and than maybe we did in the past. So there's a couple ways to protect that subgrade. Certainly doing a rough grade that does not get you all the way down to subgrade right off the bat, and really not driving on that final subgrade surface. So where we go and do our rough grade within 6 inches, so we go in, we do our rough grade out, maybe we leave it 6 inches proud, do the majority of our earthwork, and then maybe we come in with our equipment and we peel back and we remove the last 6 inches and really not allow any equipment to operate on that subgrade, and we back ourselves out, and then we come back and then we fill our aggregate base in, and then we come in and place our pavement that way. So to really think about how not to drive directly on that finished subgrade and to really think about that process and describe that process and the requirements of that process in the documents. Erosion and sediment control. So this is another big area of learning too, and in fact in the new manual there's a new element in the SWIP for protection of LID facilities. And so that's now element 13 needs to be addressed on the SWIP to show how we are going to protect our LID BMPs, and so it needs to be explicitly described in the SWIP. But also we need to install the full complement of erosion control and divert flows as necessary away from LID facilities, and describe a remediation process in the documents. I think that's really, really important to be explicit about that in construction documents, to get everybody on the same page so that we're all clear, and to go over it at the pre-con to understand what is the expectation and then what is the required remedy if there's a deviation. Because I think the required remedy can be extensive, and that needs to be in everybody's mind, and particularly the contractor's mind going into the process, so that they know what's on the table if something goes sideways, and that helps them pay a little closer attention. So the prime forms all the subs. We maintain erosion control, and we keep that siltation from happening. It's about sequencing. Number one is probably the most important thing, and then protection of the work second. Even with all that in place, things can go sideways, and that's where I mentioned you got to make sure that we've got remedy procedures described in the documents so that it's not a subjective process when we have a situation like you see there with some siltation happening onto the permeable pavement on the left there, or you can see how there was a tar placed in the bottom photo for that landscaping material, and of course it got dumped right on the pervious sidewalk. And so we need to basically anticipate these things and really plan for them. The industry is learning, but we're certainly not there yet. My project in Arlington, I put every bell and whistle in the documents I could and all over the erosion control plan in bold letters and extra orange barrier fence and signage and the whole pre-con meeting and the whole thing, and still they overcompacted the driveway. And this is a huge issue. It's something we really need to pay attention to, and probably something that requires multiple visitations during the construction process to be successful. We need to advance the industry on this. So, and then there are times when it goes really well, like this photo here. We've got our sandbags there to prevent premature run-on coming into this bioretention area. So they've got it sandbagged and they've got everything laid back and really nicely protected. So that's the goal, but sometimes, unfortunately, this is the reality. So we need to be mindful of that. The post-installation inspection and verification procedures that we're going to talk about here are an element that is a high degree of discussion happening about, well, it's part of a larger discussion, is what are the appropriate ASTM tests to use during construction, verification during construction, and verification after construction that we have an installation per plans. And I think the big message is that we do not have although it's shifting, but we in general do not have the full complement of ASTM test procedures that we do for traditional construction. And so there's a whole array of tests and approach that different people use and that are in different specifications of different jurisdictions. The permeable concrete dimension of that is the one I'm most familiar with, but I think it applies generally to all the systems. And so just say that there's, so I'm going to present what is done, what is commonly done, and we can talk about it. Each of these tests kind of have pros, cons. They have people who think they're great, people who think they don't work or they're not appropriate. And so infiltration testing is one of them. And again, particularly in the permeable concrete world, the test procedure, the ASTM 1701, is actually a test that's intended for O&M to assess when your pavement needs O&M, and is not really set up as a verification process, but some use it, some don't, but it's out there and it's available. What the number should be in the spec is hotly debated. I mean, one of the issues is that depending on how prescriptive we are in our mix design, again, using concrete as the example, and what rock we require to use, and what, can we achieve all of those factors? Is that achievable? And what number? Can we achieve 250 inches an hour post-construction in permeable concrete if we're also prescribing the aggregate to be a certain aggregate, for example, and and what those numbers should be. So, but anyway, suffice it to say, there are infiltration test procedures, and they're described here, available. In my opinion, aesthetics is probably the chief post-construction verification process, and to come up with quantitative descriptors of what we're looking for in terms of uniformity of surface type, surface texture, and divots. In the concrete world, its amount of paste smearing and so forth is also an area that's coming to some consensus, but specifications go a lot of different directions on that score. Having a panel that we place on site that we all agree meets our aesthetic requirements, and then using that as a on-site guide is the best approach. So the whole issue of sediment contamination, so after we've built our product and we're coming out for our maybe our final walkthrough or our post-installation inspection, certainly right off the bat we're looking for contamination. Contamination from uncontrolled runoff, contamination from vehicles tracking material onto the pavement off-site. And then with the plastic grids, the note is to check the staking. One of the very common post-construction issues with the plastic grid materials is dealing with the edge. Some of the products, we're going to pass them around later, are relatively thin, like the Grass Pave 2. It's a relatively light gauge section, and that stuff tends to curl and tends to pose a tripping hazard. And so getting those edges dealt with and getting any differential settlement, say you put down your permeable plastic grid material, and then you put your landscaping in and you put them in flush, and then 3 months later the adjacent landscaping settles a little bit and you now have a tripping hazard. That's a very common post-construction issue with the pavers, and so really making sure that edge is secured and that the adjacent grade is dealt with. The maintenance And operations, we have a whole module just on maintenance and operations, and in the anticipated certificate process that's probably going to follow in the next couple of years, there may even be a certificate just on O&M for those who are in public works operations whose sole focus is kind of the long-term care of these systems. The run-on from adjacent impervious surfaces issue is kind of a key O&M issue that's related to design. Being very, very careful when we do that, and in general, avoiding having run-on, I think is where we should be. We should avoid running impervious pavement onto our pervious unless we absolutely have to, and if we absolutely have to, then to know that the expectation is a significantly higher maintenance effort to deal with the kind of the supercharging of the amount of pollutants fines that are going to show up in that first couple inches of the permeable pavement. Because 1 square foot of permeable pavement can deal with sort of 1 square foot of deposition of fines, but if you have 20 feet of impermeable pavement draining on, that first inch or two of the permeable pavement is now going to be dealing with 20 lineal feet. So it's a kind of a hypercharging. We need to have the O&M to deal with that. Is snow management. Now this is less of an issue here in Western Washington. I think we certainly do deal with snow, but not to the extent that we do in the east. And when I've worked in snow prone and freezing prone areas, this becomes a heightened importance of an issue. So it's really important that we limit the sanding of this pavement, basically eliminating it where we can. This is problematic except so if we're in a freezing area where sanding is common and frequent. I had a project in Missoula, and so they really wanted to use permeable pavement at this project. And so what's the salting and sanding process? It's like, well, we are going to use a kind of a fine gravel, coarse sand aggregate. They called it chicken grit, and that's what they typically use out there. And that aggregate that they were going to apply was very, very close to what we would typically see in the voids of a interlocking permeable paver. And so in that case, we're like, oh, that kind of works. I guess if you're going to put that material on for your snow removal, for your sanding, that could be consistent. I was like, well, how certain are we that that's going to happen every single time? That we're not going to come out with a load of silty sand and dump that on there? It's like, well, they weren't able to assure us of that, and so that's a big concern. And so I think when we're within an institutional setting where we have really good controls on what that material that we're going to use for sanding is, then I think it's probably acceptable to use permeable pavement where we're going to have a sanding load. But where we're going to be relatively uncertain of what material they're going to come out and dump on the pavement, I have been very, very hesitant to use permeable pavement in those situations, and that other LID practices, I think, rise to the top. And so on that project in Missoula, after thinking about it, we decided to use bioretention instead of permeable in those cases. Now, with that said, the University of New Hampshire, UMass Amherst, all have successful cold weather permeable pavement applications within those institutional settings where they can really control those practices. And I guess I would point those who are interested in this topic, or who are going to work in more snow-prone areas, to really use the University of New Hampshire, which is my alma mater, although none of this research was happening when I was there, because they are really the kind of low impact development cold regions research institution, and so they've got lots of research. So that snow management issue, that salting and sanding issue aside, we want to also think about plows, and typically institutions that are going to plow permeable pavement will put a little rubber edge on the bottom of the plows to prevent that corner of that plow from picking up either the edge of a paver or gouging or otherwise catching on the relatively more roughened surface of a permeable pavement. With that said, there are a whole bunch of advantages to using permeable pavement in freezing conditions. It's particularly from a safety point of view, for those who have maybe spent any time in the East, who know how critical an issue of black ice can be, where we get daytime thawing and then nighttime freezing of water. Permeable pavement deals with black ice really, really easily, because once we get that melt, that water drains away, and so it's really, really nice from a safety point of view. Do you seal the joint between the permeable and the impermeable? I wouldn't think so, because you're not going to maintain, because right next to the seal, it would be unsealed. Right, currently, permeable pavement is not considered a water quality BMP. So I think in your water quality section, Curtis is going to discuss some of the treatment processes that are happening in the pavement. However, if we do not have our required CEC in the subsurface soils, then we are not going to be able to claim any water quality credit. Right, so the question is, if you have a situation where you have a client who really wants to use permeable, but you're on a grade maybe up above 10%, maybe you've got 5 feet to a restrictive layer. Not knowing anything else about the situation, that to me feels like it's probably outside the lines of where you practically would want to consider pervious pavement. I think, in a situation like that, I would be looking hard at bioretention as maybe being a more likely scenario.